Yeah, good evening to Vandal. Today we will discuss the fourth unit, that is heteroscedasticity. So within the heteroscedasticity, we have some subtopic, that is what is mean by heteroscedasticity and what is the nature of the heteroscedasticity and causes and consequences. Today we will discuss. So this is the main topic which is in our fourth module, heteroscedasticity. Heteroscedasticity. So in the introduction part, we will come to know that what is meant by heteroscedasticity and homoscedasticity. So as we discussed in the third module, we discussed about that what are the assumptions of classical linear regression model, that is called CLRM, classical linear regression model. So we have discussed within the classical linear regression model. So that is one assumption, that is the particular regression model. Nothing but there is no heteroscedasticity. There is no heteroscedasticity. What it means heteroscedasticity? And before knowing that heteroscedasticity, so we can come to know that what is meant by homoscedasticity, homoscedasticity or homoscedastic. Okay. So generally, I'm repeating that the assumption of CLRM, there is a classical linear regression model, is that the disturbances have all the same variance, nothing but so whatever we get then disturbance, there is a error values. When we estimate that the variance for all the observations are the same. When you are estimating that, when you get that variance of all the observation is same, that is called homoscedastic, homoscedastic or homoscedasticity, homoscedasticity. So generally we can indicate variance is nothing but sigma square, sigma square. So this is when this condition holds, the error comes are homoscedastic. When homoscedastic, simple you can remember. Homoscedastic means simple. Homo nothing but we can say that in microeconomics also homogeneous, nothing but equal or same. So see, homo nothing but equal in your economics equal, and scedastic nothing but or scedasticity nothing but spread, nothing but how much is spreading, nothing but is there any equal spread or unequal spreading of the variance or of the random term or error term or random term. So which means that errors have the same scatter regardless of the values of x, regardless of value of the x. Simple here I'm repeating that homoscedasticity means the same variance or equal variance of the error term, equal variance of the error term. Okay, or simple in our economics terminology, the disturbances have the same variance. Disturbances have all the same variance, That is called homoscedasticity or homoscedastic. Okay. So this is the main thing, homoscedasticity. Then heteroscedasticity. It is very quite opposite to the homoscedasticity. So generally we discuss about heterogeneous commodities, heterogeneous goods, nothing but different. So here in econometrics, when the scatter of the errors is different, nothing but when you consider the error values of the disturbance is not equal for the each and observation. For example, in some observation we will get some variance, another observation we will get some different variance. So if the variance of the error term is different or not same, that is called heteroscedasticity. Heteroscedasticity. So simple you can see heteroscedasticity means hetero nothing but unequal. Scedasticity means spread. How much spreading? Nothing but whether it is equal spreading or unequal spreading. So that is called heteroscedasticity. Heteroscedasticity. Simple, I am repeating. Please observe that if the disturbances have not the same variance, the disturbances nothing but here, disturbance nothing but here, error term, that is a ui or epsilon I or ei or et also we can mention e or u or epsilon. That is called disturbances or error term or random term or disturbances. Okay, so see, when we are getting the disturbances have not the same variance for the whole observation is called heteroscedasticity. Heteroscedasticity. So again repeating, heteroscedasticity means hetero means unequal, scedasticity means spread. Homoscedasticity, homo nothing but equal, hetero nothing but unequal. See, generally, we can write a regression model. That is a simple regression. Y is equal beta plus beta 1 x1. Sorry, could I hear mistake something? And ui. See here, yi is equal to beta 0 plus beta 1 x1 plus ui. Okay. So there's a typical mistake. Don't confuse. So here, see, when you are estimate the variance, there is a u is nothing but variance or error term or random term. So when you estimate the error term value, that is we can indicate it sigma square, sigma square. So when you are estimating the variance is equal for the all the observation, that is called homoscedasticity. Okay. Heteroscedasticity is nothing but when you are estimating the error values of the variance is unequal. That is called heteroscedasticity. Heteroscedasticity. So here the formulas are same, but we need to consider that the variance. If it is same, homoscedasticity. If it is not same, heteroscedasticity. So generally, as I repeating that, that is one whatever we have that assumptions of classical regression. There is a CLRM that the variance of UI, the error term is constant. That is called homoscedastic. But constant is nothing but same, which cannot be changes. That is called homoscedasticity. So heteroscedasticity means is a systematic pattern in errors when the variance of the errors are not constant. So here heteroscedasticity is nothing but non-constant, nothing but which can be changes one variable to the another variable. If the variance of the error term is changes, that is called heteroscedasticity. So heteroscedasticity occurs when the variance of the error term is different across the observation. So as I told you that from the beginning, that the variance of the error term is differ of the across the observations. For example, if you take 30 observations, so if you take into account that the variance of the each observation is different from the another observation, that is called heteroscedasticity. Heteroscedasticity. Have you understood about this concept clearly? Dear students, Saraswati and other people, who is this? Maheshwari, Dev,
Yes, sir.
Kambalapalli, Sir Kompal, Jaypal, Maheshwari and other people, Monica, Shivkumar, Srikanth.
Yes, sir.
Who is open?
Sir.
Yeah.
Clear, sir.
Okay. Then we'll do the next slide. See, for example, suppose if you take 100 students enroll in a typing class, for example, I'm repeating, see. For example, if you take 100 students who is enrolled in the typing class, for example, you have all the 100 students, those who are joined in the typing class, typing. So some of which have typing experience. For example, out of 100, some may have the experience, they have some experience to know how they are going to type, and some of which do not. Some of they don't have the experience. So out of 100, some have they have the experience, some they don't have the experience. What will happen? Those who have the more experience, they will type fastly, and they will not make more mistakes. Those who have the more experience. For example, those who don't have the more experience, so they will type mistakenly, nothing but the typical mistakes, and their speed is very slow, right? So, for example, if you take after the first class, there would be a great deal of dispersion in the number of typing mistakes. For example, see, after taking a first class, what will happen? So, we will observe that most of the people will complete to the mistakes. So, those who don't have the experience, Okay. So, after the final class, the dispersion would be smaller. For example, at the starting first class, when those who are typing master, so they will test the people, 100 people. So the first class, what he will get? So he will get more nothing but most of the students they have typed mistakenly. At the end of the class, after the completion of the final classes, nothing but after coach, nothing but after training. So the dispersion would be small, nothing but their mistake will be small. For example, see, if I give any paragraph to you, so what you can do, you can type it within 1 minute, for example. So within 1 minute, you may complete to do some mistakes. There's a 10 mistakes, for example. So after training 1 month, so will you able to do some mistakes? You may be complete to mistake 1 or 2, but you cannot do 10 mistakes. Am I right, dear students? Hello. Hello, Monica.
Hello, sir.
Have you
Sir.
understood?
Understood.
Maheshwari, other people. Okay, see, when the training is happening, so the dispersion, nothing but the variation would be smaller. The variation will be decreases. So the error variance is non-constant. It falls as time increases. Nothing but when the time increases, nothing but when you are spending more time for training, so you will come to do the mistake only one or two, but you cannot do more mistakes. Then I'm going to do example. See, so number of hours practice. For example, when you're doing practice 1 hour, you may do number of mistakes 10. If you practice 2 hours, you will get 8 errors. If you increase your time 3 hours, you may take complete to mistake 6 times, 6 mistakes, for example. So what you observe here, when you are practicing more and more, you will get less mistakes. Nothing but you will do less mistakes. So as number of practicing hours increases, the average number of typing errors as well as their variance decreases. The variance will be decreases. So simple what you observe, see when you are increasing your number of hours for the practice, so you will get less mistakes. Nothing but you will come to do less mistakes because you are going to get more experience. You are going to get more experience. So when you're getting more experience, you will do less mistakes, less mistakes. So when you're getting less mistakes, the variance would be decreases. The variance would be decreases. So I think I hope you understood this example. Yeah. Then see next one. See if you take a graphical representation, how we can identify whether the homoscedastic distribution or heteroscedastic distribution. See these are homoscedastic distribution. For example, each and observation if you take into consider when you draw a straight line. So on the straight line you will find out that is the error values or the actual value and estimate value. Okay. So when you take into consider this value, when you write an when you plot this normal distribution curve, so you will take there is a disturbance is equal. Nothing but the spread is the left side and the right side. It would be equal. So when you get that kind of graph, that is called homoscedastic distribution. See when you observe these three graphs, so you see the three graphs are very similar. Left side and the right side, left side and the right side, and right side and the left side, right? So this is called homoscedastic distributions or disturbances, right? So for example, I will show you that heteroscedastic distribution or disturbances. See for one observation, see how it has spreading. Nothing but see the actual value is different from the estimate value. And the actual value is different from the estimate value. See three values. How the three graphs are looking. See when you observe, this is a high level. Peak. It's a normal distribution, which is platocrat, right? See, when you observe these three diagrams, the three diagrams are not so different. What you have understood here, the spread is very high, and your spread is less, and here the spread is very less. When compared with this and this, here spread is very less. It means that see, when you observe, when you estimate the error term values, so if there is all the errors values are similar. For example, first observation, if you get two, error value is two. For second observation, if you get two, and third observation, if you get two, that is equal variance. For example, if you in another example, if first observation, if you get error value is three, the second observation, if you get error value is one, for the third observation, if you get error value is five. So 2, 1, 5. Which is very different. Nothing but you're not getting the disturbance value is equal. So when you're getting a disturbance value is different, so your the variance of the error term would be not constant, not constant. So we can observe by looking at these diagrams. So am I clear, dear students, about heteroscedastic disturbances and homoscedastic? Simple, you can observe these graphs which are not similar. So if you observe the earlier graph, see similar graphs. Homoscedastic, heteroscedastic. Have you observed? Dear students, Monica and the Maheshwari, Oppo, Shivakumar, and other people. Srikant, Supriya.
Yes, sir.
Clear?
Yes, sir. Clear.
Okay. So I'm going to repeat other diagrams also. See, if you take error value, see, this is a heteroscedasticity, nothing but here the peak level, here normal, here very leptocratic. Okay. For example, see, if you observe for the poor people and rich people, so the variation is very high in the poor people. The rich people, the variation is very less. For example, within the poor people, there is some different people are there, and with the rich people, they are allied people. So the variation will be very small. Okay. See, this is the called normal distribution. Sometimes we will write like this also. See, this is a linear straight line curve. Okay, so this is estimated value or actual value, actual values. This is estimated values. See, when you take into consideration this and this difference. So if there is a equal variance, nothing but so these dots are very close to the straight line. Have you observed these points? These dots, which dots are very close to the straight line or trend line. So when the dots are very close to this line, this is called homoscedastic pattern of errors. For example, if you observe that the heteroscedastic pattern, see here there is a small and as see here the spread is very high. Have you observed? Srikant and Monica, other Maheshwari and other people, Shivakumar. Hello. You should be
Sir.
respond,
Sir.
otherwise I cannot understand whether you are understood or not.
Yes, sir, it is clear.
Okay. Okay. So the different if the these dots are very away from this line, it is called heteroscedastic. Okay. If the dots are very close to this line, this is called homoscedastic. Homoscedastic. Then, for example, when you are getting this kind of dots, so what we can observe, we need to understand what are the causes of this kind of pattern is happening. So see, that is called causes or reasons of heteroscedasticity. So this is a very important topic. What are the causes or reasons for heteroscedasticity? What are the causes of heteroscedasticity and what are the reasons for heteroscedasticity? So there are 4 or 5 reasons which are very important to understand that. So what is the reason for heteroscedasticity? The first one is a presence of outliers in the data. So first one is the presence of outlier in the data. So can anybody can you tell you that what is meant by outliers in the data? Outliers. So outliers in the data nothing but, for example, if the data is, for example, when you're conducting examination, if somebody will get, for example, the marks out of 100, 60, 70, 80, 60, 70, 80, 65, 75, 85. For example, if somebody gets 0, the 0 is nothing but is an outlier. So if you get 100, there is an outlier, nothing but which is away from the iron average. We can say that is the extreme values. Extreme values also we can call the outliers. Okay. So one by one we'll discuss. And second one, incorrect functional form of regression model. So when you are running a regression model, please keep in mind that which function is there and which kind of function form you are following, and incorrect transformation of the data. So what type of data you are using, whether your data is transformation or not. Then for example, sometimes when you are mixing the variables with the different measure scales, such as high income households with the lower income households. For example, if you take the data from the higher income people and lower income people, so you will get some heteroscedasticity problem because their income levels are different from the lower income level people. For example, if I'm taking to consider, what is your for example, if your father is a farmer, the farmer you may get income is for annum 1 lakh, for example. If I take a collector income, those the students whose father is collector, so his income is more than 10 lakhs or 50 lakhs, 10 lakhs, right? So when you're taking such kind of data, you will get a heteroscedastic problem. Have you understood these 4 or 5 topics, reasons? Then one by one we will discuss. Then first one is the presence of outlier. Presence of outliers in the data. For example, see, as I presented the data on production from 2014 to 2020. So, for example, 2014, 10 quintals, 12, 16, then 17, 32 quintals, 17, 18, 17 quintals, 18, 19 quintals, 20, 14 quintals. So, when you observe this data, so which is 32 is the highest value, which is not very similar to this data. Am I right? So, this 32 is called outlier. Outlier, nothing but when you calculate average, so without taking 32, you will get an average 15 to 16, right? So here when you had this 32, you will get different values. So here note in 17 the production is very high, that is 32, it is called outlier. Okay, so the conclusion and exclusion of the such an observation, especially if the sample size is small. For example, if you take sample size of this only 7 or 8 years, 7 years, 32. If you take more number of observations from 20, 30, 50, 70, 90, 100 years, so you may get data. So why we can get this kind of data? So if you take the small size, you will get a problem of outliers. So when you increase the sample size, you may not get outliers possibilities there. Okay, in 2021 or 2013, 12, 2011, 2011, it may be 31, 32, 33. So when you are getting the such kind of data, so the data is not an outlier, right? Have you understood about the presence of outlier in the data?
Yes, sir.
The next one, so incorrect functional form of the regression model. So what is incorrect functional form of the regression model? For example, see, as per psychological law of consumption function, the CF is nothing but psychological law of consumption function. So what the theory says? So there is a relationship between the income and consumption, right? So as income increases, the consumption increases. For example, when you are going to estimate, there is a consumption function. C is a function of rainfall. If I take into consider that consumption is depends on the rainfall, so that is called incorrect function form. So what should I take into consider? Consumption is function of income. That is correct function form.
Yes, sir.
So when you are estimating the model, please keep in mind that which are the dependent variable, which are the independent variable. So when you're taking independent variable, whether the independent variables are influencing the dependent variable or not, directly or not. So please be correct when you're running a model. So please keep in mind that is that whether the particular variable is influencing or not. So here, now heteroscedasticity may be due to the fact of some important variables are omitted from the model. Sometimes, see, when you are taking to consider, for example, if you take consumption of ice creams, it depends on the rainfall. See, nowadays, most of the trending is nothing but if there is a rainfall, most of the people will try to consume the ice creams in cities, not in villages. So sometimes instead of taking income, sometimes the people remove the nothing but the people cannot consider income as an independent variable. So when they are not able to take income as an independent variable, they will get a heteroscedastic problem. Heteroscedasticity problem. Am I clear, dear students, about this incorrect functional form of the regression model?
Yes, sir.
Yes. Then next one, third one, incorrect transformation of the data. So how we can transfer the data, that is the main important in the regression model when you are estimating the model. So heteroscedasticity can also arise because of incorrect data transformation. So that is a log and linear or ratio or first difference. So as I told you when the beginning of multicollinearity and autocorrelation, So all in order to get a similar, nothing but in order to maintain the similarity of all the variables, we need to transfer all the variables in the log form. For example, if you convert only one variable as an independent variable, only convert into log form. Otherwise, if you're not able to convert it, so you will get multicollinearity problem, heteroscedasticity problem. So, for example, as I told you that consumption is function of income and rainfall. For example, if I take into consider, so if I consider only if I transfer the income into log form, but if I not consider the rainfall, so I may get heteroscedasticity problem. So all the variables should, whatever we are considering all the variables, we should transfer into the same form, that is a log form or natural logarithm form or ratios, or sometimes we will take first difference. Okay. So when you are getting multicollinear problems, so you need to do the first difference method. So note that the problem of heteroscedasticity is likely to be more common in cross-section data. So please keep in mind, which is a very important topic. Heteroscedasticity is likely to be more common in cross-sectional data than time series data. So when you're taking a sample data from the population, so you will get a heteroscedasticity problem. But when you are estimating the model in time series, you may get less, nothing but you may get a heteroscedasticity problem, but less time you will get. Generally, you will get a multiple heteroscedasticity problem when you are taking a sample or cross-section data. For example, sample response income and savings are different from the village to village. For example, if you take the sample response from the village income and savings, if I consider that income of the Nizamabad people, farmers, if I consider that other major district farmers' income, the difference is very high because they are cultivating different crops, and here they are cultivating different crops. Okay, so their savings also different from that village to village, mandal to mandal, state to state, village, region to region. Within the Nizamabad, the farmers' income is different. For example, if you take Bodan or the Armour area and other area, the farmers' income is different, and their savings are different. So that is called when you take the sample data, you will get heteroscedasticity problem. I may clear about this incorrect function form transformation of the data. Then fourth one, mixing observation with a different measures of scale. So see, as I told you that, for example, when you are mixing the observations with the different measures of scale. So for example, such as high income households with lower income households. When you observe, when you consider that lower income people and higher income people are, the best example is rich and poor. So rich and poor. If we consider richer income and poorer income. For example, see, in order to estimate that consumption level of Hyderabad people. In Hyderabad, there are rich people are there and poor people are there. For example, if you collect the information from the rich people and poor people, when you combine these two data, when you are going to estimate the model, you will get a heteroscedasticity problem. Okay, so in Hyderabad, some areas some areas people's income is different, and in rich areas, for example, you take Banjara Hills and Jubilee Hills, their income level is different. Okay, so when you combine these two types of data, you will get a heteroscedasticity problem. The fifth one, if more regressors included in the model. For example, see, when you take into consideration model, so if the more regressors are nothing but here independent variables included in the model. So when you take more number of independent variables, you will get heteroscedasticity problem. Because which one we can, for example, sometimes we will think that so all the variables can influence the dependent variable. But so we need to take which variables are more influence than others. That are variables only we need to take. But some people will take all the variables. For example, GDP can influence by the number of variables. Our GDP will be influenced by the n number of variables. But if you consider all the variables, you will get heteroscedasticity problem. Only you need to take a proxy variables. For example, see, if you consider that income consumption is dependent on the income. If I take income and wealth as an independent variable, two independent variables, consumption is function of income, comma, wealth. So if I consider the two variables, so I will get heteroscedasticity problem. So instead of taking both, I need to take only one, either income or wealth. So that is the thing that, so more more regressions included in the model. I think I hope you understood about this more regressors, nothing but independent variables included in the model. Hello?
Yes, sir. Yes, sir. It is clear.
Yeah. Then heteroscedasticity arises from violating the assumptions of CLRM. For example, when you are estimating that model,
ఇంతమంది అటెండ్ అయినందుకే నాకు ఇంట్రెస్ట్ వస్తలేదు.
please see when you are
నేనంటున్నా.
violating that
14
CLRM
మంది వచ్చిండ్రు.
model, that the regression model is not correctly specified. For example, say when you are estimating the model,
యాడ్ అవుతాడు ఈ క్లాస్ కి ఒక్కరికి యాడ్ అవుతాడు.
please unmute. So heteroscedasticity arises from the violating the assumptions of CLRM. When you are estimating the model, when you are violating that some assumptions, you will get heteroscedasticity problem. That is a classical linear regression, that the regression model is not correctly specified. So at the same time, when you are avoiding some assumptions, you will get a problem. Not only heteroscedasticity problem, you will get a multipolarity problem, you will get autocorrelation problem also. Okay. So these are the causes, these are the main causes of heteroscedasticity. Please keep in mind that I'm repeating, there are 6 causes of heteroscedasticity. First one is the presence of outliers. Second one is the incorrect functional form of the regression model. And third one, incorrect transformation of the data. Fourth one, mixing observation with the different measures of scale. And fifth one, if the more regressor included in the model, then sixth one is if you are violating the CLRM assumptions. So these are the 6 points which are very important. So these are causes of heteroscedasticity. So there are others also there. So I will discuss the data collected technique improve. For example, see when you are collecting the data technique, which data techniques you are adapting when you are collecting the sample from the population. So that is the thing that, and the nature of the phenomenon under the study may have an increasing or decreasing trend. Say consumption pattern of the food increases, as income increases. So similarly, the number of typing mistakes are decreased and number of hours practice. So sometimes observations are the in the form of averages. For example, if you take into consider that in order to, for example, in order to calculate our expenditure, for example, expenditure on education, sometimes I may take an average month wise, I may take year also, an average I will take. So when you're taking data as an average, so you will get some heteroscedasticity problem. Sometimes the theoretical consideration, that is when you are entering that model, when you are preparing that what type of model you are going to estimate, so you need to be clear that is there any theoretical background of the study or not. So as per I told you that the consumption function of income. So I may quote that the as per the psychological law of consumption function, the consumption is depends on income and other variables. So C is a dependent variable, income is a independent variable. For example, if I'm not considering the theoretical background, if I put income is depends on consumption, so there is no theoretical background of the study. So if I write that income is a function of consumption, I need to be mentioned that is there any theoretical background or is there or not. So that is the thing that we need to discuss. For example, if you take Y, that is the Y depends yield of rice, X denotes the quantity of the fertilizers. For example, see our production of the rice is that is the productivity is different, depends on quantity of the fertilizers. So what it means that as we are increasing the fertilizer to the crop, the production may be increased. For a certain level only, when you are putting more fertilizers, they will get more production. If you are increasing more fertilizers, you will not get more production. So see, it is observed that when the quantity of fertilizer increases, the yield increases. In fact, initially the yield increases, the quantity of fertilizer increases. Starting stage lo, మన fertilizer increase చేస్తుంటే quantity of production also increase. But gradually the rate of increase slowly down, because when you're putting more fertilizers to the crops, the fertilizers is increased, further the crop burns. For example, when you're increasing more fertilizers, it may harmful to the crop also. When you increase the dose, for example, when you're taking a more dose to your body, so the dose may impact the negative impact on your body. At the same time, the fertilizer also can impact negatively on the production of the rice. Have you understood about these concepts of this thing? What are the causes of heteroscedasticity?
Yes, sir. Clear, sir.
Okay, so if the time permits also, I will take the class. Are you able to listen our class? Then I will continue. Or else, so anyway, I will send the message in the WhatsApp. Then you can respond and you can join. So if you like this video, please share and subscribe. Thank you once again.